This is for pre-calculus, and what we're heading into is we're going to be learning how to graph polynomial equations, polynomial functions. They are going to be functions in this case. So what I wanted to do was just make a video that kind of summarizes everything and puts it in writing that you can refer to, if you need to. Because sometimes when I'm going over things in class, I go a little bit too fast, or I go too fast, and you don't get things written down. But and I forgot to bring my book home, so I'm doing this off the top of my head, and hopefully I'll remember everything, and we'll make this as useful as possible. So I'm going to start with cubic equations. And just like when we were working with quadratic equations, working with parabolas, they can open up or down, and that depends on the number out in the sign out in front of the factors. And y, let's just go with y equals x minus 2 times x plus 1 times x plus 3. Okay. You're not going to be given everything in factored form, but I'm going to graph everything as if it's already been factored. Okay, so this is what I'm going to be graphing, because the fact that we factor these things to get to this point isn't the lesson. The lesson is we know how to graph these things once we have it factored. So for me, it's already going to be factored for when I'm making this video. So what we do is initially we don't put anything on the y-axis. We don't put a scale on the y-axis, just the x-axis. And we plot the zeros of the function. So the zeros of the function are when I do 0 equals x minus 2 times the quantity x plus 1 times the quantity x plus 3. When I do that, then we're solving each one of these. We set each one of these equal to 0, so x minus 2 equals 0, x plus 1 equals 0, x plus 3 equals 0. And we add 2, x equals 2, x equals negative 1, x equals negative 3. I won't go to this detail. Basically, I think we are at the point where I can look at this and say the zeros are 2, negative 1, and negative 3. Okay. So if this thing out front, okay, right here, if this thing out front, and we can put an A in there temporarily if you want to, if A is greater than 0, which it is here, then I start down here, I come up through the 0, I come back down through that 0, I come back down and back up and through the last 0, and that's what my graph looks like. Okay. So how high I go on these doesn't matter right now, and that's why we're not putting a scale on the x-axis, on the y-axis. I don't care how high we go here. There is a relationship. The closer together the zeros are, usually the tighter this bump in the road. Okay, so this is probably not as accurate as it could be. I probably should have made this one a little bit smaller and this one a little bit larger. Okay, because these zeros are pretty close together compared to these zeros. And so there is a relationship between that. And that has to actually do with the concavity changing here and a lot of other factors. Okay. So if what's out front of here is positive, if there's no negative out front of here, then that's what we do. Okay. But then we can do the exact same thing. Y equals the opposite of the quantity, x minus 2, x plus 1, x plus 3. So I'm doing the exact same equation, except now I put a negative out front of it. So My zeros are the same, positive 2, positive 2, negative 1, and negative 3. Okay? Except up here, positive out front, I start down here and 1 up first. Negative out front, I do the opposite. I start up here now, and I'm going to come down through here, back up, back, and back. And there we are if we're negative out front. So the way I remember it, and that's not always the best way, but the way I remember it is that if it's positive out front, it does the opposite of what I think it should do. It starts down here in negative land and goes up first. Up is positive, maybe, I don't know. But if it has a negative out front, then it does the opposite of what I think it should do. It starts up here in positive land and goes negative first. And a cubic equation should have 3 zeros and 2 bumps in the road, I call them. Okay, 3 zeros and 2 bumps in the road. 1, 2, 3 zeros and 1, 2 bumps in the road. Okay, so a quartic would have 4 zeros and 3 bumps in the road. A quintic would have 5 zeros and 4 bumps in the road, etc., and so on. Unless, remember the fundamental theorem of algebra. The fundamental theorem of algebra says any cubic equation is going to have 3 zeros. But you can also have what we call a triple root, or you can have a double root, plus 1. So if you have a double root plus 1, that's 3 zeros. If you have a triple root, that's 3 zeros. So here's how we handle triple roots and double roots. And triple roots and double roots can occur not just in cubics, but in quartics. A quartic equation can have a triple root and then plus 1. It could also have 2 double roots. It could also have 1 double root plus 2. But the roots all add up to 4 for a quartic and a 3 for a cubic. Okay, so triple root first. If I graph y equals x cubed, I'm just going to graph it, and I'm going to put a y-axis on there. Well, I'm going to put a scale on the y-axis, and here's why. If ever I'm given something on a standardized test on anything, and I don't know how to graph it, I can always plug in numbers and plot points. Okay, and obviously, you know, I could start at -2, and -2 to the third power is -8. And then if I plug in -1, -1 to the third power is -1. If I plug in 0, 0 to the third power is 0. And then if I plug in +1, I get 1. If I plug in +2, I get 8. Okay. Now I plot those points. 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. So -2, -8, -1, 1, 0, 0, 1, 1, 2, 8. And, whoa, my almost missed. That's what it looks like. That's y equals x cubed. Put a negative in there, it would have opened the other way. Down going like that. And 0 is a triple root. So whenever we have a triple root, okay, triple root, like we do in this case, then the graph does what I call a shoot through. Okay, so it's going to climb, it's going to shoot through, and then on up. Okay, the graph does a shoot through. And that's with any triple root. If I'm graphing a quartic equation with a triple root, there's going to be a shoot through at that triple root. If I'm graphing an 8th degree equation with 2 triple roots, there's going to be a triple root at both of those. Okay? So at a triple root, we shoot through. And then we should already know from graphing the quadratic equations that if I have a double root is a point of tangency. Okay, because when we had a double root and the double root was the vertex, and the vertex was tangent to the x-axis then. So that's what happens when we have a double root within a cubic equation. So oops, I don't want to put y's on there, sorry. Get rid of that. So my zeros are at +1, and that's a double root, and -4, and that's a single root. It's positive out front, so it's going to start down here, right? It's going to start down because it's positive out front. It's going to come up through here. It's actually going to go pretty high because these are pretty far apart. But it's going to come down. It'll be tangent here, and then like this, okay? And there's your double root. And whether I'm graphing a quartic, a quintic, a 8th degree, if I have a double root, there's going to be a point of tangency. It's just the way it is. Okay. So those are pretty much cubics, and what we do when we have a triple root versus what we do when we have a double root. Okay. So then from cubics we go to quartic. And so we might have something like y equals, let's see, x minus 2 times x minus 4 times x plus 1 times x plus 3. Okay, 4 factors. Fundamental theorem of algebra, if it's a quartic, there's going to be 4 zeros, 4 answers, 4 roots, 4 whatever you want to call them. Okay. Molly. Sorry, dog's barking outside. I had to make sure my girls were okay. And everybody's okay. Everybody's good. Okay. Sorry for the interruption. Not only am I trying to keep track of them, I'm trying to watch the Bronco game. It's just a mess going on here. Anyway, so what I do is I plot these zeros. X equals 2, x equals 4, x equals -1, x equals -3. Okay. Now, positive out front. Think of a quadratic. I'm going to pull another piece of paper over here. Think of a quadratic. Okay. Whatever it is. If we're positive out front, if a is greater than 0, it opens up. And if a is less than 0, then that quadratic opens down, right? it's going to be the same for a quartic, okay? If I am positive out front, basically it's going to open up. So it's going to come, down through here, up, probably a little higher. Well, I'm not going to hit that, am I? Out of practice. Down through here, and then back up through here, okay? And these bumps in the road are not going to be at the same places because this isn't symmetric. But if it opens up, I say if it's positive out front, it opens up. So to me, this is opening up. Some people have problems with this bump in the road and calling it opening up. I don't know. I don't know any other way to describe it. Or we're positive out front, so we start up here in positive land and go down first, and then back up, and then back down, and then back up, and so on. The other thing the other way I like to think of it is if I were to pour water into this thing, okay, over the top. If I were to pour water over the top, then this would hold water. The what's going up part of it. So if this were negative out front, if it were y equals the opposite of x minus 2, x minus 4, x plus 1, x plus 3, then when we graph this one, 2, 3, 4, 3, 4, positive 2, positive 4, negative 1, negative 3. So because this one is negative out front, to me it's going to open down. So that means I'm going to start down here in negative land, go up and down through, and so on. And it looks something like this. And if I were to pour water into here or into here, it's not going to hold water. To me, this is opening down. There's more of it that's opening down than there is opening up. So, and notice I have 1, 2, 3, 4 zeros and 1, 2, 3 bumps in the road. Okay. What I failed to say was that we were back here with the cubics, okay, with the cubic equation. Any odd degreed equation is going to act like that, okay, the same way. Any odd degree equation would act like that, okay? And now that we're with quartics, and that's the reason I went back and explained the open up, open down thing with parabolas, is because that's an even degreed function. And any even degreed function is going to act like that. For this one, it's an even degreed function. A 6th degree would be an even degreed function. It would behave like this. An 8th degree, a 10th degree, etc., and so on. Okay. So what happens if we get double root, triple root, etc., and so on? Well, here's one that they really like to give you, and the reason is because they make it symmetrical. So in other words, they do y equals x plus 2 quantity squared times x minus 2 quantity squared. It's really a pretty graph. So we count off here. And again, we're not putting anything on the y-axis because I don't care where those intercepts are or how high those bumps in the road are going. So this is going to be a double root at negative 2 and a double root at positive 2. And so the bumps in the road are going to be the same size. Okay. So I'm going to, and it's positive out front, so I'm going to start up here in positive land. And it's going to come down. It's going to be tangent. It's going to go up the same amount, come down the same amount, be tangent, and go back up. And you got 2 double roots. And because we have 2 double roots, we have 2 points of tangency. And that's the whole idea behind those double roots. The hardest one to draw for me is when there's a triple root and a single root, like y equals x minus 1 cubed times x plus 3. So we have I want to make this one plus and this one minus. I do better with these going left to right rather than the other way around. So I have a triple root at -1 and then a root at 3 because that gives me 4 zeros, right? So I do a shoot through here, and then it'll come up and make a bump in the road and down. And they're actually, if you exaggerate it enough, there's still 3 bumps in the road. And there's your shoot through for your triple root. So anyway, these are challenging to graph and they're just kind of fun. So I just wanted to make a video, and seniors are going to be gone on Wednesday, so I thought this might be helpful for them as well. But we certainly will go over some of these in class and look at them a little bit more closely, as well as some of the other anomalies that they're going to throw at you. So hope this helps, and that I am out.